Hello friends, welcome back to my channel. Today's topic is OSI model and we will be understanding the 7 layers of network communication in this video. If you are watching for the first time, request you to subscribe my channel, and if you are liking my video, please click on the like button. Let's see what is OSI model. The OSI model is a 7-layer framework that standardizes network communication and solves the interoperability issues. Layering means decomposing the problem of building a network into more manageable components. It is easy to troubleshoot. The purpose of OSI model is to establish the communication between two systems without requiring changes to the logic of underlying hardware and software. Each OSI layer performs specific tasks and communicate with adjacent layers to ensure smooth data transmission. Modularity allows network issues to be isolated to specific layers, simplifying troubleshooting and reducing the downtime. The OSI model is essential for network education certifications and provide a reference for modern network design. In OSI model, physical layer is like cable and hardware. Data link layer handles MAC addresses, network layer handles IP addresses, layer 4 to layer 7 are transport, session, presentation and application is all about how data is getting transferred from point A to point B. Each layer plays important role. If any layer get fails, then your connection fails. So to troubleshoot network problem, knowledge of OSI model is mandatory. Now we will see layers in OSI model. As we know, there are 7 layers in OSI model. So first layer is physical layer, second is data link layer, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and seventh is application layer. Suppose there are two systems, system A and system B. These two systems are connected to network through a LAN cable, and there will be intermediary node, and we need to transfer data from system A to system B. So here system A will be act as the source system and system B will be act as the receiver system. Suppose system A is opening a application. That application will be generating the data and that data will be transferred to application layer. Then application layer will be transferring the data to presentation layer. Presentation layer will be transferring to session layer. Session layer will be transferring to transport layer. Transport layer will be transferring to network layer. Network layer will be transferring to data link layer. Data link layer will be transferring to physical layer. Through this physical layer, data will be placed to the cable and cable will be transferring the data to another physical layer, and then physical layer again will transfer the data to data link layer. Data link layer will be transferring to network layer. Network layer will be transferring to transport layer. Transport layer will be transferring to session layer. Session layer will be transferring to presentation layer. Presentation layer will be transferring to application layer, and this application layer will be transferring the data to receiver system. So always remember, in receiver system it will be always 1 to 7, mean data will be transferred from physical layer to application layer, and in source system it will be always 7 to 1, data will be transferring from application layer to physical layer. And There will be always interaction between two adjacent layers. Like presentation layer will be interacting with application layer. Also presentation layer will be interacting with session layer. Same way network layer will be interacting with transport layer, also with data link layer. The topmost upper layer of the OSI model is application layer. This layer connects user directly to the network services through communication protocol like HTTP and SMTP. Key application layer protocol includes HTTP, HTTPS for web browsing, SMTP for email, DNS for domain resolution, and FTP for file transfer. Security at this application layer is very vital, involving multi-factor authentication, API gateways, and firewalls to protect the sensitive data. Monitoring the application layer ensures service availability and user satisfaction, as failure can disrupt productivity and experience. Next is presentation layer. This layer translates and encodes the data to ensure compatibility between different system format and characters encodings. Encryption technologies like TLS at the presentation layer protect sensitive information during data transmission over the network. Compression reduces bandwidth consumption and enhances network performance by minimizing data size during transmission. The presentation layer consistently encodes and decodes multimedia format like JPEG, PNG, MPEG, and GIF for smooth communication. Session layer. This layer handles session creation, synchronization, checkpointing, and orderly termination for reliable communication. Applications like video conferencing, remote desktop, and database rely on persistent session for continuous data exchange. Checkpoints allow resuming interrupted communication without restarting, enhancing reliability and user experience. Session management maintains user login state during service access, supporting secure and continuous authentication workflows. Transport layer. Transport layer provides end-to-end communication, error recovery, flow control, and reliable data transfer between the devices. TCP offers connection-oriented communication with acknowledgement, sequencing, and retransmission for the reliability. UDP provides connectionless communication with low overhead, ideal for streaming, gaming, and real-time apps. Port number direct transport layer traffic to the specific application. Example, HTTPS uses TCP port 443. In-depth TCP protocol, UDP protocol, port and port numbers we will be discussing in my next video. Next is network layer. Network layer manages logical addressing and route packets across interconnected networks using IP protocols. Routing protocols like OSPF, EIGRP, and BGP determine efficient path between routers for packet forwarding. What is OSPF, EIGRP, and BGP? We will discuss in my next videos. Key function includes path selection, packet forwarding, fragmentation, and addressing to support the connectivity. Network layer design ensures scalability, efficient traffic flow, and includes cybersecurity control like ACLS. Next is data link layer. This layer ensures reliable communication by managing framing, MAC addressing, and error detection within local networks. Ethernet is dominant technology at layer 2 with switches forwarding frames based on MAC addresses to control the network traffic. VLAN technology enables logical separation of network traffic to improve security and manageability in shared environment. Error detection mechanism like frame checks prevent transmission issues, aiding network troubleshooting and reliability. In-depth VLAN and what is MAC address, all those things we will be discussing in my next video. Next is physical layer. This layer transmits raw bits over various media including electrical and optical signals, defining hardware characteristics. Devices like repeaters, hub, transceivers and patch panels operates at the physical layer to manage bit transmission. Common issues like cable damage, signal loss, electromagnetic interface and hardware failures affecting the connectivity. High-speed fiber optics and modern wireless technologies improve bandwidth and reduce latency between physical networks. Devices, data moves down OSI layers with each adding control information for transmission. Receiving devices remove headers and trailers as data moves up through the layers. Encapsulation ensures addressing, sequencing, error detection, and routing for delivery. Fundamental knowledge for packet analysis, troubleshooting, and cybersecurity investigations. Now we will be seeing how OSI model used for network troubleshooting. To start troubleshooting at the physical layer by checking cables, interfaces and power before moving upward through the layers. Then begin troubleshooting with applications and services, then analyze underlying protocols and infrastructure step by step, then mapping network symptoms to OSI layers enables efficient isolation and resolution of connectivity problems. The OSI model supports training, documentation and security analysis in network operation. Thank you all for watching my video.